Hello, this is the Three Musketeers design video for ME 2110 final competition. Our members are Courtney Wolpop, a second-year ME, Brett Peloki, a third-year ME, and Roy Shi, a second-year ME. Our goal is to build a well-integrated, competition-winning robot. The goal of this project is to design and build an autonomous system to compete against other teams in the final 2110 Toy Story-themed competition. The objective is to maximize points scored while being constrained by many factors. The objective of the final competition is to complete the tasks: launch the system, rescue Buzz, launch the rocket, return the RC cars to the correct quadrant, return the toy to the minivan, and egress. Teams have 3 minutes to set up the competition items inside their device and 40 seconds to complete the tasks while competing against 3 other teams in the same arena. The competition area is set up into 3 sectors: the starting zone, home zone, and centerpiece. The robot begins in the starting zone, Buzz and the aliens are located in the home zone, and each team's quadrant is located in the centerpiece along with the minivan. The chassis, toy arm, and RC car ramp are laser cut using birch plywood. The scissor lift uses structural half-inch plywood for the arms. The wheels and motor solenoid mounts are 3D printed. The final iteration of the device will use a mousetrap to power the drivetrain along with a 5:1 ratio gear train. The mousetrap is fixed to the chassis floor and will be triggered by a solenoid that activates at the start. Torque is transferred to the wheels with a 5:1 ratio gear train utilizing a string and spool. To receive maximum points for rescuing Buzz, the system should remove Buzz from Pizza Planet and return him to the starting zone without disturbing any aliens. Our mechanism of mousetrap mounted at a 35-degree angle to hit Buzz out of Pizza Planet into the starting zone without disturbing the aliens. This mechanism is triggered by the same solenoid that's used to activate the RC car deployment mechanism. The third task is to launch the rocket to a minimum of 42 inches above the arena, with bonus points being scored for the highest or second highest rocket. Our scissor lift design is mounted on a drawer slide and uses a motor and 2 rubber bands as energy sources. Test data regarding actuation force allowed us to size the gears to supply enough force to reach 100 inches. The scissor lift actuates when a motor attached to a 3:1 gear train mounted at the top of the robot pulls the bottom link upward via a string. 2 rubber bands pull the bottom 2 links together, assisting in motion. To receive max points for the 4th task, all 3 RC cars should be returned to the correct quadrant color. You can score points for other teams by putting your cars into their quadrant, so it's important to be careful. Our RC car deployment mechanism will use a switch to detect the location of the correct quadrant through the extruded blocks mounted on the centerpiece. Once the switch is triggered, a solenoid will retract, releasing the cars down a ramp into the quadrant. Points for the 5th task are earned by releasing the toy into the roof of the rotating minivan located on top of the centerpiece. The rotating beacons will hit a switch on the robot, rotating the wooden arm using a motor. The momentum of the arm holds the toy in open pen until the arm stops. Our robot earns a multiplier of 2 for partial egress by moving out of the starting zone. We accomplish this by retracting the toy arm from the centerpiece. We decide to laser cut as many parts as possible to minimize tolerance and make a professional-looking robot. However, laser cutting and gluing the pieces together was time and labor intensive. Due to lengthy manufacturing time, we often could not test as much as we would like, which hurt us in many competitions. In the future, we'd like a less intensive design, which we get more time to test.